Welcome back again. Thank you for joining me. Today we're going to do our day 2 notes of this multiplying and dividing radical expressions. Today focusing on the dividing piece. So I'm going to do a little review from exponential algebra first. All right. So when dividing two square roots, you should have already seen this, okay? Have an idea of what's going on. So remember, when you're dividing and you have both things inside the square root, remember, the first way to tackle these problems is I would reduce that fraction. So 3 over 12 reduces to 1 over 4. So the first way to tackle these problems is reduce your fraction. That'll make things 10 times easier for you if you do that. Because look at what we ended up with. Square root of 1 is just 1. Square root of 4 is 2. And then boom, we're done. All right, so be cognizant of that. If you can reduce your fraction, do so because your life will be so much easier if you remember this. All right, so jumping into the real meat of today. So I've already mentioned this, but before you simplify the radical, make sure you reduce the fraction first. Also remember, when dividing, you subtract your exponents. All right, so let's take a look at this. What is the simplest form of each quotient? All right, now here, notice we're dealing with even indexes. So that means we're going to have to take into account our absolute value in the end. But first, 18 divided by 2 gives me 9. X to the 5 divided by x to the 3. Remember, that means we are subtracting our exponents. We get 2. All right, now, when taking this out of our radical, well, the square root of 9 is actually already a perfect square. And then the square root of x squared, well, remember, we take that exponent, we divide it by the index. 2 divided by 2 leaves me 1. Because we're dealing with an even index, remember, we have to consider the absolute value. Well, the cool thing is that number, we can just pull out, okay? Remember, you can always just pull out that number. However, the x, because it has an odd exponent, has to stay inside that absolute value. Okay? Now for this next one, we're in luck. We're dealing with an odd index, so we're not going to have to consider that absolute value stuff. We just get to simplify this one. Now again, the first thing I'm going to do is I'm going to simplify my fraction. 162 divided by 3 leaves me with 54. Y to the 5 divided by y to the 2. Well, 5 minus 2 leaves me a y to the third. All right, so looking at that 54, that I'm going to need my power chart for. So look under the third power. You can see that 54 is going to split up into 27 and 2. 27 times 2 gives us that 54. So what I'm going to do now, that cubed root of 27 is the number 3. Well, that 2 has to stay inside. And remember, I'm going to give myself some space to work. Now, that y to the 3, remember, I take my exponent divided by the index. Well, 3 divided by 3 just leaves me the 1 outside. So that is going to be my final answer to this. All right. Looking at our next one. So the first thing I'm going to do is simplify this. 50 divided by 2 leaves me with 25. And now x squared divided by x to the 6. So 2 minus 6 leaves me with a negative 4. What that exponent means, that negative exponent means, I'm going to have it on the bottom instead. Okay? So that x to the 4 is actually going to be on the bottom. So now we take a look at this. Now one thing to remember, this has an even index, so I am going to have to consider my absolute value. Square root of 25 is 5. Square root of x to the 4. Divide the exponent by the index. 4 divided by 2. Now, I do have to consider my absolute value here. Now, the cool thing is though, 5 is just a number, so it doesn't have to worry about it. X squared, it has an even exponent, so it's going to be positive no matter what. So in this case, I actually don't need the absolute value, but still be in the habit of considering the absolute value. All right. Now, with division, if you remember from Expo, with division, sometimes you're going to end up with a radical in the denominator. Now remember, mathematicians have decided that that is not simplified. Okay, so we have to go through a special process. That process is called rationalizing the denominator. And if you remember from Expo, it was multiplying top and bottom by the radical you're trying to get rid of. Because when you're dealing with square roots, if you think about completing what you're missing. So for square root, if you have a 2, well, that means you're missing another 2 to complete that radical. So you multiply top and bottom by it because that means you're getting the square root of 2 over the square root of 4. And again, the square root of 4, we know what that is. We know that that's 2. So now realize that got rid of a radical in the denominator. And we can actually follow that same process for higher powered ones as well. Okay, the process looks a little bit different, however, it is essentially the same. So let's take a look at what that looks like. So, first step, reduce the fraction. Second step, for each number and each variable in the denominator, identify how many of each are missing to make the radical complete. And then multiply top and bottom of the fraction by those missing pieces and simplify. So, here we go. Now the cool thing is here, this is odd, an odd index. We don't have to worry about our absolute values. So the first thing is to reduce the fraction. So notice 14 over 10 reduces to 7 over 5. All right, so again, first step, just reduce the fraction. Now I have to look to see what is going to make my bottom complete. All right, so we're dealing with a cubed root. So I have a 5 there. Well, to complete that, that means I need 2 more 5s. All right, so that means I need a 25 here. Again, my goal is to complete that cube. Here I have a y squared. So I already have 2 of them. So to complete those y's, that means I need 1 more. And to follow the process, I have to multiply top and bottom by that same thing. Okay? So on top, we are getting the cubed root of 175xy. And the cool thing is, if you reduce it first, you're not going to have to worry about simplifying that at all. That's already going to be simplified. So that's kind of the nice thing about this process. On the bottom, when you multiply those, 5 times 5 times 25 is 125. Y squared times y is y cubed. And again, the goal is the fact that that bottom piece completely comes outside of the radical. Okay, because the cubed root of 125 is just 5. The cubed root of y cubed is just y. So again, the goal is that the bottom will always be able to remove itself from the radical. If it doesn't, it means you haven't quite gotten that perfect cube. Okay? Now, let's look at another example, shall we? So, this next one again, we're dealing with an odd index. So the cool thing is we don't have to worry about the absolute value. Now, looking at those numbers and variables, this time the radical actually doesn't simplify at all. The fraction doesn't reduce, okay? Which means our problem is that there is a radical in the denominator. Remember, that means it's not simplified. So, let's take a look at what is missing from the bottom. So, I have a 6 there. Well, that means what's missing is 2 more 6's. So 6 squared is missing. I've got a y down there. Well, to complete the cube, that means I need another y, so I can get up to 3. I have a z. Now, that means to complete it, I need a z squared, okay, because I need 3 of them. Now again, in the process of rationalizing the denominator, we need to multiply top and bottom by the same thing. So we get that. Now, let's simplify this. So on top, 5 times 36 gives me 180. Then I have x squared y z squared. On the bottom, let's see what I've got. 216 y cubed z cubed. And again, what you should notice about that bottom, when you combine them, you should have something that is a perfect cube, okay? The cubed root of 216 is just 6. Your chart should tell you that. Cubed root of y cubed is y. Cubed root of z cubed is z. Again, in the end, you should always get something that can come completely outside the radical. If it doesn't, it means you have not found the right missing pieces to complete the radical. All right? All right, so that is going to be all for our notes today. Again, I thank you for joining me for these notes. Please make sure you have everything written down so you can come to class tomorrow ready to do your practice work.